Arithmetic operators are the symbols that tell a program to perform basic math. The most common ones are: plus addition adds two numbers, for example 3 plus 5 gives 8. Think of adding two piles of apples. Minus subtraction subtracts the second operand from the first, for example 10 minus 4 gives 6. Like taking 4 apples away from a basket of 10. Times multiplication multiplies two numbers, for example 7 times 2 gives 14. It's the same as adding the first number to itself the second number of times. Divided by division divides the first operand by the second, for example 20 divided by 5 gives 4. Imagine sharing 20 candies equally among 5 friends. Modulus gives the remainder after integer division, for example 22, modulus 6 gives 4 because 6 fits 3 times into 22, leaving 4 left over. This is useful for what's left over after dividing. The syntax in most languages is result equals operand 1 operator operand 2. All operators work with numeric data types such as int, float, or double. When several arithmetic operators appear in one expression, the language decides which one to evaluate first. This decision follows operator precedence like the order of operations in school parentheses, then multiplication or division, then addition or subtraction. For example, in a plus b times c, the multiplication b times c happens before the addition, yielding a plus b times c. Associativity determines how operators of the same precedence are grouped. Most arithmetic operators are left to right associative, meaning a minus b minus c is evaluated as a minus b, then minus c. The exception is the assignment operator equals, which is right to left. Using parentheses lets you override the default order just as you would in a math problem. A plus b times c forces the addition to happen first. Understanding precedence prevents bugs such as writing int total equals price plus tax times discount when you really meant price plus tax times discount. The increment plus plus and decrement minus minus operators change a variable's value by exactly 1. They come in two forms: prefix plus plus I or minus minus I. The variable is changed before the surrounding expression uses its value. Example: int I equals 5 semicolon int j equals plus plus I semicolon results in I equals 6 and j equals 6. Postfix I plus plus or I minus minus. The original value is used first, then the variable is changed. Example: int I equals 5 semicolon int j equals I plus plus semicolon gives I equals 6 but j equals 5. A common real-world analogy is a ticket counter. Prefix is like checking the next ticket number before handing it out. Postfix is handing out the current ticket and then moving the counter forward. In loops for int I equals 0 semicolon I less than 10 semicolon I plus plus, the postfix form is typical because the loop body uses the old value of I before it increments. Relational operators compare two values and produce a Boolean result, true or false. The main symbols are: less than is true if left operand is smaller. Greater than is true if left operand is larger. Less than or equal is true if left is smaller or exactly the same. Greater than or equal is true if left is larger or exactly the same. Equality is true if both operands hold the same value. Inequality is true if the operands differ. For example, age greater than or equal to 18 checks if a person is an adult. The syntax is result equals operand 1 operator operand 2, where the result is a Boolean variable or directly used in a condition like if score less than 50. All numeric types can be compared, and strings can be compared lexicographically in many languages. A truth table lists every possible combination of input values and the resulting Boolean output for a relational operator. For a single comparison, there are only two outcomes. 5 less than 10 is true. 5 greater than 10 is false. 5 equal to 5 is true. 5 not equal to 5 is false. 7 less than or equal to 7 is true. 7 greater than or equal to 7 is true. When multiple relational expressions are combined with logical operators, and/or the overall truth table grows, but each individual comparison still follows the simple true or false pattern shown above. Arithmetic and relational operators often appear together inside if while, or for statements to decide which path a program should take. Int A equals 4, B equals 7, C equals 10. If a plus B times 2 greater than C, then print big enough, else print too small. First, a plus B equals 4 plus 7 gives 11. Times 2 gives 22. Then the greater than operator checks if 22 is greater than C, which is 10. Because it is true, the first block executes. This demonstrates how you can embed calculations inside conditions, allowing decisions based on computed values rather than just raw variables. Explanations: several subtle mistakes happen frequently. Assignment equals versus equality double equals. If x equals 5 assigns 5 to x and then evaluates the expression, which is true for any non-zero value. The intended test should be if x double equals 5. Many compilers warn about this. Integer division. When both operands are integers, divide discards the fractional part. 7 divided by 2 yields 3, not 3.5. To get a floating point result, cast one operand, float 7 divided by 2 yields 3.5. Typecasting. Mixing types can cause unexpected truncation or overflow. For example, char C equals 200 may wraparound because a char often holds only -128 to 127. Explicit casts int double clarify the intended conversion and avoid silent data loss. Being aware of these pitfalls prevents logic errors that are hard to debug. Evaluate the expression. Int x equals 5, y equals 2. Int result equals x plus minus y times 3. Step by step, minus y makes y become 1, then 1 times 3 equals 3. X plus uses 5, then increments x to 6. So result equals 5 plus 3 equals 8. What does the following condition print? Int A equals 10, B equals 3. If a divided by B equals 3 and a modulo B equals 1, then print yes. A divided by B integer division is 3, a modulo B is 1, both conditions true, prints yes. Find the Boolean value of open parentheses 7 minus 2 close parentheses times 2 greater than 10 close parentheses, or open parentheses 5 equals 5 and 0 close parentheses. 7 minus 2 times 2 equals 10, 10 greater than 10 is false. 5 equals 5 is true, 0 is false, so true and false is false. Overall false or false is false. Correct the mistake. Int flag equals 0. If flag equals 1, then use double equals for comparison. If flag double equals 1, then